in section 2 we did direct variation, which we talked about was like a specific type of line that goes through the origin. Now we're just going to do all the other lines. So, in order to graph lines, in order to write equations of lines, you kind of have to understand the idea of slope, which is just a rate of change. Okay, rate is just a measurement of how you're changing. A rate as like a ratio. So a measurement as a ratio that compares two different things that are changing. So maybe x is changing this way, y is changing this way, and then we have a ratio that represents that change. That ratio with direct variation was known as k. Here we call it m for slope. So the slope formula is here. You can interchange that. It can be y2 minus y1 over x2 minus x1. That's fine. You just can't mix and match it. So it can't be something like y1 minus y2 over x2 minus x1. You can't do that. You want to make sure you're subtracting the same way. It doesn't matter if you call, one point the x1, y1, or that point you could call x2, y2. It's all relative, so that doesn't matter either. You just want to stay consistent. You got point 1, you got point 2. This is slope-intercept form. We'll also do other forms of lines. They're all on that yellow poster. So we'll do standard form and we'll do point slope form. We won't do 2-point form. That's kind of unnecessary. And we don't really do 2-intercept form, but we do the top 3 up there. So all we're going to do is just find the slope. We're going to pick a point. We're going to call it point 1, or we're going to pick another point, call it point 2. I'm going to call this point 1. This is going to be point 2. Doesn't matter which way we subtract as long as we're consistent. So you can either say -3 minus -2, and then 7 minus 4, or you can do 4 minus 7 and -2 minus -3. You should get the same slope regardless. You just want to make sure you're subtracting the same direction. So up top here, 7 minus 4 is 3. -3 minus a -2 is like -3 plus 2, so that's -1. This simplifies to -3. If I do it the other way, I get -3 over -2 minus -3, that's like +3, so that's a 1. This simplifies to -3. So you see we get the same slope either way. We get -3. You want to make sure that you always put the y's on top of the x's. If you're subtracting a negative, put that number in parentheses. If you don't, that's where all the mistakes happen. So if you're subtracting a negative number, put it in parentheses so you don't mess up the signs. What's 1 minus 1?
0.
What is 3 minus -4?
7.
What's 0 divided by 7?
0.
Can a line have a slope of 0?
Yeah.
Yeah. What does it look like?
Vertex.
Well, that's vague. They're all straight
Flat.
lines.
Like
Horizontal
a horizontal
line, right?
line, yeah.
All right, so a 0 slope is a horizontal line. The equation of something that has a 0 slope. So it's kind of like it's rising nothing and then running 7, right? It's got a rise of nothing and then just like keeps running, and so that's why it's horizontal. So a horizontally sloped line will go through one y value. So it'll look like something like y equals a number. That's what the equation of the line will look like. Whereas a positive slope or a negative slope will look like y equals mx plus b, most likely, or we could put it in a, we put it in other forms, but we're focusing on slope-intercept form today. All right, so find the slope between them. Rise all the time and don't run. You just go up, 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 up. So an undefined slope is a vertical line. It's the only line that's not a function. Vertical lines don't pass the vertical line test. Okay, and they will go through one x value and look something like x equals some constant. Because they go through the x-axis at a value, and it's going to be x is this all the time. For the second line, So we should get positive 1 and then positive 9. Positive 1 over 9.
Yeah.
I did get that.
So a positive slope is
No.
increasing everywhere.
Which is a little before.
So that means it goes up from left to right. Negative slope, like this one, is decreasing everywhere. That means it goes down from left to right.
Can it go down the other way?
What other way?
Can it go down? Wait.
It goes down from left to right.
Okay.
Silly goose.
So like you read a book, left to right, you read a line, left to right. So this is going up, this is going down, this is just hanging out, this is meh. We also call this like a constant function. Because it's not changing, it's just going straight. Don't mess with my stapler.
Yeah, Michael.
So now what we're going to do is write equations of lines. We know how to find the slope. I'm going to show you how to do the rest. So it says Daniel has saved $3. So in his wallet, he's got $3. And then after 5 more days of saving, he has saved $14. So if we were to consider those points, or consider that as points on a graph, after 0 days, he has $3, right? Like just, you know, he just like already has $3. After 5 days, right, he has $14. So we're gonna assume that this is a linear equation and write a linear equation model for it. So we make assumptions sometimes in math when we write models. We assume it's linear, we assume it's quadratic, we assume it's something else. Sometimes the calculator can run tests and tell us what is the best model for something. Okay? We're gonna assume that this is linear so that he's gonna continue to save the same amount of money every like 5 days. We're gonna use these points to find a slope. The way I wrote the points that way, I got that information because we're looking for how much he saves each day. Days is the independent variable, and the money is the dependent variable. How much he is saving depends on how many days have passed, right? So that's how we know which one's gonna be our y and which one's gonna be our x. So you have to figure out which one's depending on what. Remember, with direct variation, there were situations where it probably could have gone either way. In this situation, there's a right way. How much he's saving depends on how many days have passed. You don't have to use x and y, you can use other things. Okay, so we don't have to use x and y, we can use whatever we want, but we have to define our variables.
Oh.
So if you want to use like, I don't know, like d for dollars instead of y, or if you wanted to use like t for time instead of that, or I don't know, whatever you want to do. You can use d for days. You just have to define your variables. So somewhere you're going to say, I'm going to erase this, is that okay? Everyone's got that somewhere? I'm going to run out of room if I don't. So somewhere I'm going to say, let y equal amount saved and x be the number of days. Okay? So we're going to first find the slope. We know how to do that. We take the y's and we subtract them. We take the x's and we subtract them. And we simplify. So 3 minus 14 is negative 11.
Over -5.
0 minus 5 is negative 5. That simplifies to positive 11 over 5. So don't forget, if there's 2 negatives, that simplifies to a positive. 1 negative, that'll be negative. That's my slope. Now the equation is y equals mx plus b for a line. What does b represent in y equals mx plus b?
$3 that he started with.
But in general, so yes, but more general, yeah. Exactly, B is the y-intercept. And the y-intercept is what? Like, what is a y-intercept?
No,
The
it's
value we start with?
The value you start with, or, what were you gonna
point
say?
of the graph you start with, right?
Well, usually, but not necessarily, we don't have to start with that.
Oh.
But like, what do you, like, where is that on the graph? Like, what do you?
Oh.
On the y.
It's on the y-axis. So the points on the y-axis always start with 0, right? Do you see how we have the y-intercept? They gave that to us. It's the value we started with, 3. So our equation can be y equals 11/5 x plus 3 because our y-intercept is 3. Now if they don't give us the y-intercept, we have to find it, but we didn't have to do that, so we'll do that later. So this would be our linear equation that models how much he saves every day. So we started with $3, and this means he's gaining 11/5 the dollar every day. That like kind of doesn't make sense. We would probably think of it more of it as a decimal, but usually when we, graph lines, we like to see our slope as a fraction, so it's fine. How much will Daniel have on the 7th day? So 7th day, is this representing x or a y?
X.
That's representing an x, yeah. So if it says, when will he have $100, that would be a y. If it says, how much will he have on the 7th day, that's representing an x of 7. So what we want to do is substitute x of 7 in. And just do that. Bless you. So 11/5 times 7 is 77/5 plus 3 over 1. You would want to find a common denominator for that. So what would our common denominator be? 5. So we'd probably multiply this by 5 to get the common denominator. So that's 15/5. 77 plus 15 is like 92/5. Now, if I'm talking about money, is 92/5 helpful?
No.
Not really. So we would probably want to divide. So 5 goes into 9 once with 4 left over. 5 goes into 42 8 times with 2 left over. So that's 18 2/5. Some of you may know the decimal conversion. I'm going to show you real quick. With fifths, it's really easy. They're all like 2s. So, well, I don't know if that's the right way to describe it. So 1/5 is 0.2. 2/5 is 0.4. 3/5 is 0.6. 4/5 is 0.8. And then 5/5 would be like 1.0. So see how that goes? So just so you know, in case you've forgotten, like the fifths decimals, they just kind of go by 0.2s instead of like, because they're like 1/5 is like, I don't know, it's like 2/10. So it's kind of like tenths where you go by like 0.1, 0.2, 0.3, 0.4, but we have to like double it. So anywho, so this is going to be 18 point what? 2/5 is going to be 0.4. If we're talking about money, how would we want to like answer this question? How much will Daniel have?
$18.40.
Exactly. Daniel will have $18.40 on day 7. Assuming that this trend is going to continue and assuming that the trend is linear. So your weight is being affected by how much time has passed. So the months or the time that's passed, that's your independent variable. So I'm going to say that can be x. You could also use like m if you want, whatever. And then your weight, like how much weight he's lost, that's going to be your dependent variable. It depends on how much time has passed. So weight loss. So that's why I wrote my points 1, 5, and then 2, 7. So to find your slope, you want to do y's over x's. So 7 minus 5 is 2 over 1. Your slope is 2. So our equation of our line is y equals mx plus b. In this question, we had the b. In this question, we don't have the b. B is the value for y when x is 0. We don't have that. We have like 1, 5. So we don't have b. So to find b, we're going to take one of these points. And take one of those points, doesn't matter which one. I'm going to pick this one because the numbers are smaller. I'm going to plug x in for x, y in for y, and use that to solve for b. Okay, so what do we get? We get 5 equals 2 plus b. I'm getting ahead of myself here. Which means b is 3. Okay, so if b is 3, we can finish writing our equation. Y equals 2x plus 37. That's our equation. When will he lose 12 pounds? So is 12 pounds an x or a y?
Y.
Mm-hmm. So we're going to plug 12 in for y and solve for x. Sometimes you're solving for x, sometimes you're solving for y. You just want to pay attention to, what you did. So we'd subtract 3, we get 9, and then divide. So you get 4.5. So 4.5 what? Yeah, so Dudley will lose
No, I got that.
12 pounds in 4.5 months. Baxter is filling a water tank. After 1 minute of filling, the tank has 63 gallons of water. After 5 minutes, it has 95 gallons of water. Okay. What depends on what? Gallons depend on minutes. So that means I'm going to use different letters this time. I'm going to let G be number of gallons, and then M equal number of minutes, just to show you that it doesn't matter what letters you use. But G is kind of like our Y, and M is kind of like our X, because the number of minutes that pass affect how many gallons are going into the tank thing. So our 2 points are 1 minute, 63, and then 5 minutes, 95. Those are our 2 points. So what's the first step? Find the slope. Find the slope. So I'm going to do 95 minus 63 over 5 minus 1. So that's going to be 32 over 4, which goes in evenly at 8. So the slope is 8. Now, do we have a y-intercept?
Yes. Wait.
No. We'll find our y-intercept. So right now our equation is G equals 8m plus b. If you use x, it's fine. And then we can use one of our points. Let's take, I guess, this one. We're going to plug x into x, or in this case, x into m. And then we're going to take 63 and put that in for gallons, because it's representing gallons. Well, you're not dividing. So this says 63 equals 8 plus b. So you would just subtract 8 to find b. So 63 minus 8 is 55. Right? So that would be our intercept. So our equation is G equals 8m plus 55. Some models, like when you interpret the y-intercept, they like make sense, and sometimes they don't. Sometimes we just kind of have to have a model. In this particular example, this 55 means that there were already 55 gallons of water in the tank, like at the beginning. So like after no time has passed, there were 55 gallons of water in the tank. And the slope means that after every 1 minute, the gallon is going to increase by 8 gallons tank capacity. So the change in y, or the change in gallons, is 8, the change in x is 1. So after 1 minute, 8 gallons will increase, or it will increase by 8 gallons. Does that make sense?
Yeah.
So that's what that equation's kind of representing in words. It says find the volume of the water tank 25 minutes after Baxter begins filling the tank. So 25 minutes is what? M or G? M, minutes. So G equals 8 times 25 plus 55. At some point, it's going to be important for you to know what slope-intercept form is, etc., like what all the different forms are, and not confuse them. So slope-intercept has the slope and the intercept in it. So that's why it's y equals mx plus b. To start, so this is our equation, we're trying to get y by itself. So to start, we would subtract 5x from both sides of the equation, because that's over there on the left, we want it on the right. That's what y equals mx plus b looks like. So we'd be left with negative 4y equals negative 5x plus 16. We don't want to write 16 minus 5x, because that's not y equals mx plus b. We want to write the negative 5x first, and then the 16. And then we divide everything by negative 4. And so we're left with y equals positive 5/4 x minus 4. That would be slope-intercept form. Now, one thing that's nice about slope-intercept form is it has one of the intercepts in it. It says find the x and the y intercept. If you properly put it in slope-intercept form, you already have the y-intercept. It's b. So it's 0, negative 4. If you're not sure that you did it correctly and you would like to try to find it like a different way, you want to plug 0 in for x and solve for y. Okay, so you would go to your original equation, you would plug in 0, and solve. So what happens? You multiply 5 times 0, this goes away, you get negative 4y equals 16, y equals negative 4. Oh look, we found it, it's good. Once you find it, I want you to always write it as a point. The y-intercept is a point, it's not y equals negative 4. Y equals negative 4 is a line. Okay, 0, negative 4 is a point, so make sure that when you're identifying points, you write them as points and not just like y equals this. To find the x value, what do we do? What are we going to plug?
Y equals 0.
We're going to plug 0 in for y, and then solve for x. Basically the backwards version of what we just did. So remember to use your original equation. You can use the manipulated equation, but if you mess this up, you're going to get it wrong. So I always recommend using the original equation if you did something to it. So what happens? This goes away. We get 5x equals 16. X is 16/5, which is 3.2, or 3 1/5. So that means our x-intercept is 3.2, comma 0. Or you could put 16/5, comma 0. Or you could put 3 1/5. 0. When you graph it, you probably don't want to graph the x-intercept because it's not like a pleasant number to graph. You can though. So we do have a y-intercept, that's nice, 1, 2, 3, 4, negative 4. You can graph your x-intercept if you want. It's like right there, but it's not very accurate. So what's something that we can use instead of that? Instead of using the x-intercept, what can we use to graph? Yeah, slope. So remember our slope is 5/4. So from this point, from a point on your graph, not just random places, not the origin, this isn't direct variation, from this point we could go up 1, 2, 3, 4, 5, and then which way?
Right.
To the right. 1, 2, 3, 4. See how that puts us like right around, like right in line with this ickier point. And then we would just, you know, grab a ruler and ta-da! So just remember, with a slope of 5/4, you can either go up 5 and to the right 4, because those are positive numbers, positive over positive, or you can go down 5 and to the left 4. A negative over a negative is still a positive, so you could also go down 5 and to the left 4. We just didn't do that because it didn't fit on the graph, so that didn't make sense, but sometimes it will make sense to go the other way, different scenarios. So always make sure you can do the slope both ways. It's a positive slope, so it should be going up and to the right. Positive increase. See how there's a bunch of fractions in here? We can get rid of the fractions. To get rid of the fractions, you want to look at the denominators of the fractions and multiply the equation by something that those numbers, those denominator numbers, go into. What's a number that 4 and 2 go into?
8.
Yeah, what else? 4. 4 is better.
4.
You can use 8 though, it's fine. 8's good, but 4 is better because it's smaller. So we're gonna multiply the entire equation by 4, which means we're multiplying each piece by 4. You don't have to do this necessarily, but if you don't like the fractions and you want to just get rid of them at the beginning, this is how you can do it. So here, the 4's cancel, you get negative 3x. 4 times a half is 2, so that's going to be 2y. And 4 times negative 1 is negative 4. So that just gets rid of the fractions for you. Now how do we get y by itself?
You
Add the 3x. So negative 2y equals 3x plus 4. Am I done? Oh, it is minus 4, thank you. Minus 4. Yeah, so I'm not done, I still have to divide by negative 2. Okay, so when I divide by negative 2, I get y equals negative 3 over 2x plus 2, because negative 4 over negative 2 is going to be positive 2. So that's slope-intercept form. Yay! Questions? All right, x and y intercepts. To find the x-intercept, you want to plug in 0 for y and solve for x. When you plug in 0 for y, this whole term goes away. We get negative 3/4 x equals negative 1. What times 3/4 is 1?
It's just 4 thirds.
Yeah, it's the reciprocal. Multiply by the reciprocal, you get 4/3.
Wait, can you plug it into the equation where you get rid of the fractions, or is that not the same?
You can, as long as you didn't mess it up. So as long as it's correctly fractionless, yes, you can. So 4/3, comma, 0. Okay, y-intercept, we already have. What is it? 2. The b. Now if we wanted to graph it using the intercept, we would have a y-intercept of 2, and then an x-intercept of 4/3. Now an x-intercept of 4/3 is like 1 1/3. So that's going to be like right here. Don't graph a point like a slope. Okay, so don't graph 4/3 like up 4/3. That's not a thing. It's not a rate of change. It's just a point. So you would graph it like a value. If you want to use the slope, you have to come back to this guy and use him. Okay, so if it says negative 3/2, you can either go up 3, and then which way? Left 2. Or you can go down 3 and to the right 2. Those are your options. So you can go up 3 to the left 2, or down 3 to the right 2. one of the directions has to be negative in order for it to be a negative slope, which it is. So we wanna make sure our line is going down and to the right. Ta-da. Questions?
I got my graph in reverse.
Graph went the other way.
I originally got this slope as a positive.
But it's negative. Cause this is negative. When you put this over here, you would have added it, so it would have been positive over here.
Ah, I see.